Numerical number 8.13. How will you weight the sun? That is, estimate its mass. The mean orbital radius of the earth around the sun is 1.5 into 10 to the power 8 kilometer. You try to understand, this is the earth which is moving around the sun, and the orbital speed of the earth we consider as VO. Then centripetal force mVO square upon r, where r is the radius of the earth around the sun. Okay, so mVO square upon r is the centripetal force. Here we have to consider mass, that of the earth. So if you write that mass as me, so it becomes the sun at the center, earth moving around the sun, orbital speed as VO, then it becomes mass of the earth as me VO square upon r, where r is the radius of the earth around the sun. Okay, so this centripetal force is provided by the gravitational attractive force, that is GMS me upon r square. If you make ms, that is mass of the sun, as subject of formula, here me will be cancelled out. Okay, then mass of the sun can be rvo square upon g. Okay, and radius is given, orbital speed is given, all the values are known to you. We just have to place those values. Radius, okay, radius is 1.5 10 to the power 11. Okay, then orbital speed is 3 into 10 raised to 4, so it becomes square of it, so it becomes 9 into 10 raised to 8. Okay, orbital speed must be given to you. It is 30 kilometer per second. If it is not given, then you should write it. It is 30 kilometer per second, so it becomes 3 into 10 raised to 4 meter per second, and square of it will give you 9 into 10 to the power 8. Okay, here 9 into 10 raised to 8 it is, and value of g is known to us, 6.67 10 to the power minus 11. Place those values and simplify this, then you get the answer of mass of the sun, which is about 2.02 into 10 to the power 30 kg. Okay, now example number 8.15. Okay, a body weight 63 Newton on the surface of the earth. What is the gravitational force on it due to the earth at a height equal to half the radius of the earth? So we are considering the body at a height which is half of the radius of the earth. Okay, now first of all, gravitational acceleration at any height is given by this formula, that is gh, or we can say gravitational acceleration at height h is given by ge upon 1 plus h upon re the whole square. Now if you simplify it by placing the value of h is nothing but re by 2. So in place of this h, we write re by 2. This re will be cancelled out. It becomes 1 by 2 the whole square, 1 plus 1 by 2 the whole square. In the numerator, ge remains as it is. Okay, so if you simplify this, now 1 plus 1 by 2 is 3 by 2, whole square will become 9 by 4, and inverse of it will give you 4 by 9. So gravitational acceleration at height h will be 4 by 9 times gravitational acceleration on the earth, that is 9.8. So we just have to place the value, okay, and you get the answer. Weight on the earth is mg. Okay, so w prime, the new weight at the height which is equal to half of the radius, will be 4 by 9 times the value of weight on the earth, that is 4 by 9 mge. Okay, and this mge, that is weight on the surface of the earth, is 63. So 4 by 9 into 63 you have to take, 9 sevens are, so it becomes 4 sevens are 28 Newton. Okay. Now 8.16, we consider the earth to be a sphere of uniform mass density. How much would a body weigh halfway down to the center of the earth if it is weighted 250 Newton on the surface? So here you are now going below the surface of the earth. Okay, so this is the earth, this is the center of the earth. Okay, you are going halfway down, that is the depth at which you are with the body is Re by 2. So this depth is Re by 2. Okay. So depth at which the object is, that is Re by 2. And gravitational acceleration at any depth is given by this equation. Okay, G at any depth is equal to G1 minus D upon Re. Instead of D you write R by 2 or Re by 2. So you will get the value of gravitational acceleration at the depth to be G upon 2. So new weight, okay, that will be mg upon 2, because we have to consider the gravitational acceleration at the depth. So weight at any depth is nothing but m, that is gravitational acceleration at depth is G by 2. So this mg is the weight on the surface of the earth, and that is 250 divided by 2. It gives you 125 Newton. Okay. Okay. A rocket is fired vertically with the speed of 5 km per second from the earth's surface. How far from the earth does the rocket go before returning to the earth? Mass of the earth is given, mean radius of the earth is given, g is value of gravitational constant is also given to us. Now try to understand that the earth is fired or it is sent from the surface of the earth. So initially the rocket will have kinetic energy plus the potential energy. When it reaches at certain height and it comes back at this particular point, try to understand, it stops for a while, so kinetic energy becomes zero at that point where it is reaching. So it will have only final kinetic energy. Final potential energy. So it will have kinetic energy finally to be zero because it stops there, and its potential energy will have some value. So initially it has kinetic plus potential energy, finally it has only potential energy. Okay. Now another thing, you have, say, this is the earth, okay, and this is the object or a rocket which is fired. Okay, so this is the rocket whose mass is, say, m. So it has kinetic energy initially to be 1/2 mv square, and this object is at distance, say, re from the center of the earth. Okay, rocket is at distance re from the center of the earth, so it will have the potential energy, that is binding energy, minus g. Okay, it will be minus g MEM upon RE. That is the potential energy. So first of all, initially it has both the energies, kinetic as well as potential, and these energies are shown to be K1 as initial kinetic energy, U1 as initial potential energy. Initial kinetic energy is 1/2 mv square, where small m is the mass of rocket, and potential energy as minus GMEM upon RE. Now we consider that this rocket reaches at height h and it stops there for a while and comes back. So its distance from the surface of the earth will be RE and the height. So total distance finally from the center of the earth will be Re plus h, and it will have only potential energy at this point, and that potential energy will be GMEM upon Re plus h. Okay, so the final potential energy will be plus, okay, this is plus, and into bracket there must be a negative sign, minus GMEM upon RE plus H. Okay, so it goes like this. At a final point from where it comes back, the potential energy will be minus GMEM upon RE plus H. Now, this term here on left hand side is taken to the right hand side and GMEM is taken common. So, it becomes 1 half mv square is equal to GMEM is common. So, 1 upon RE minus 1 upon RE plus H you will get. Okay. Now, again just we have to take the LCM, okay, in the bracket, and you simplify this, you will get H upon RE into RE plus H. Okay, here it becomes 2GME, okay, because this M will be cancelled out. So you will have V square is equal to 2GME. Inside you are taking the LCM, so it becomes RE plus H minus H upon RE into RE plus H. Okay, so this H will be cancelled out. Okay, and you will have this RE plus H minus RE will give you RE only. So here you will get 2GME into bracket, it becomes H upon RE into RE plus H. In this we have to take into consideration the LCM part. Okay, just you go through it again. Here the LCM is RE into RE plus H. Here it becomes RE plus H minus RE. So this RE will be cancelled out and you will have H upon RE into RE plus H. Now as you know, GME is equal to G into RE square. So here there is GME, we write G into RE square. Okay, this bracket remains as it is. Okay, then we just simplify this part. Okay, here 2G RE. It is RE square, but RE it becomes because 1 RE will be cancelled out. So 2G RE into bracket H upon. Now here we are taking H as common from the denominator. So in the denominator it becomes, numerator remains as it is. Okay, H is taken common in the denominator, so it becomes RE upon H plus 1. Okay, so this formula you will get. Okay, this H will be cancelled out, you can see here. Okay, so now you will get V square is equal to 2GRE 1 upon RE plus H plus 1. This answer you will get. Now this RE plus H, rather RE upon H plus 1 is taken in the numerator this side on left hand side, and on right hand side we take 2G RE upon V square. Okay, so now it is very easy to calculate the value of RE upon H. Okay, you can make RE upon H as subject of formula. This 1 goes on the other side, it becomes minus 1. Okay, place the values of G 9.8, RE radius of the earth 6.4 10 to the power 6, then V is also there. Okay, just simplify, you will get 5.0176 and subtract this one, you will get 4.0176. Okay, now you can get the value of H. H is nothing but RE upon this 4.0176 and place the value of RE. You will get the height at which the rocket is reaching, that is 1600 kilometer. Okay, so total height will be RE plus this height. So total distance the rocket is from the center will be 6400 kilometer plus 1600 kilometer, and that will be the value, that is 8000 kilometer, or we can say 8 into 10 to the power 6 meter, whichever way you want to write, because 6400 kilometer plus 1600 kilometer, so it becomes 8000 kilometer, or we write 8 into 10 to the power 6 meter. Okay. Now numerical number 8.18, the escape speed of projectile on the earth's surface is 11.2 km per second. The body is projected out with thrice this speed. You are sending the object with the speed 3 times this speed of 11.2 km per second. What is the speed of the body far away from the earth? Ignore the presence of the sun and other planets. Now initial speed is v, at which we are projecting. Final speed we consider as v prime. When the object is on the surface of the earth, it has two energies, kinetic plus potential energy. Finally, when it goes very far away, the potential energy becomes zero and kinetic energy only remains with it. Okay, so this step gives you this idea that initially it has both kinetic plus potential energy, finally it is having only kinetic energy. Okay, now as you know, VE is under root 2 GME upon RE. Okay, so if you square it, just you try to understand this way. If it is squared, then you will get VE square is equal to 2 GME upon RE. So GME upon RE, okay, GME upon RE will give you it. GME upon RE will be VE square upon 2. So instead of this GME upon RE, we write VE square upon 2. Okay, so it is having new format. That equation will have the new format. Okay, this instead of GME upon RE, it is VE square by 2, so it becomes minus 1 by 2 mVE square. Here everything is remaining as it is. 1 by 2 and m will be cancelled out from each and every steps. Okay, so the equation will have this particular format, that is v prime square. If you make a subject of formula, then it is v square minus ve square. Now v is 3 times ve, so instead of v we write 3ve, then it becomes 9ve square minus 1ve square, so it becomes 8ve square, and square root of it will give you under root 8ve. And if you write the value of escape speed to be 11.2 km per second, multiply by square root of 8, and it results to 31.7 km per second. Calculate these numericals 2-3 times in notebook. Thank you very much.